All right, so yesterday you did direct, inverse, and joint variation, and I'm pretty sure that you were able to get these off the board. If you are absent and you need a replacement copy, you can get them from your neighbor, and I'm sure they would definitely share with you. But we really would like to put it in our notebook first. So when I go to my table of contents, modeling functions with variation, my next page is 62. Now, one of the things they said in making interactive notebooks was if you can put the folded edge toward the center. So even though I wrote 62 here on my table of contents, I'm going to take this thing that I did yesterday on page 63 so that my fold line goes in the fold, and then hopefully it won't crumple when I close my thing. So go ahead and pause the video and tape your stuff in. So please go ahead and open this up, and we're going to write in the description. And I know on the video he said as X goes up, Y goes up. And the model, that's linear basically. And so the model is Y equals K times X. And it looks like this. It will always go through the origin. It will never move from there. Now I know you're used to this K being the slope, but in direct variation, since the y-intercept is 0, they choose to change this from being an M to a K. It's their visual model to say this is direct variation and not just plain old linear. Okay? All right, so that one's done. Inverse variation is when they do the opposite thing. As X gets bigger, Y gets less. And as X gets less, Y gets bigger. And notice that it doesn't go through 0, 0. They go in opposite directions. And that's why it's Y equals K times 1 divided by X. Now, joint combination variation. The reason we don't have a graph is because this is how they relate more than 2 variables. And if you relate more than 2 variables, you're no longer in the 2D XY plane and you need something else, and we don't have really anything else. But what it means is that more than one variable is influencing the dependent variable. So more than one variable is influencing the dependent variable, and they can still use the words like directly, directly proportional, inversely, inversely proportional. Okay, so it could look like this: y equals k times x times z times 1 over w. So this is still the constant, k, but these are the variables. And that's the important thing to note, is no matter what, you're going to have some sort of constant of variation. That's what it's called. And then the variables are going to be related somehow. So pause the video and get ready to get the next worksheet out. So now take your handout, and I'm going to tape it on the other page so that they're side by side. So wherever you want to tape it, pause the video and tape it there, please. So in this first problem, we notice it says A is directly proportional to both B and H, and then it gives us some values. The thing is, this is like a double question. They first want to know the relationship, and then they want to know what the constant of variation is. So the first thing I always do is figure out what directly proportional means. And directly means multiplying in the form of some constant, and this has more than one variable, so it's a joint variation problem. But this sentence truly means A equals K times B times H. Now, in the world of direct variation, the only variables are the A, B, and H. The K is the value we want to know. I wish I knew this. Now, if you have 4 variables and you want to find one of the variables' values, someone has to give you the other 3. Oh, and look how many they gave us. Coincidence? No, it's just part of the pattern. So now we substitute in these values. 10 equals K times 5 times 4. We know that 5 times 4 is 20. 10 equals K times 20. We're trying to find K, so divide both sides by 20. And it turns out that K is equal to 1/2. Here's where most students fail to finish the problem. What they want us to do now is rewrite this formula with our value for K, because K will never change. The only things that will change are these 3 variables. So our final answer is A equals 1/2 B times H. Oh, do you guys remember what formula that is? Triangle area. Who'd have thought that the formula of a triangle was a direct variation problem? I never thought of it that way, but it is. The base and the height always have to be multiplied by a constant 1/2 to find the area. Okay, cool. 24, and W is directly proportional to both R and the square of I. So again, that means W equals K times R times, and it says square of I, so you just put I to the power of 2. That's all. They could say square root, they could say absolute value. It doesn't matter, you just translate it to the math. So if you count, there's 1, 2, 3, 4 variables. This is the one we want to find. That means somebody better tell us a W and an R and an I, and lo and behold, they do. Yay, whoopee. So we get 4 equals K times 100 times 0.25 squared. That equals 4K times, and here I have to use my calculator. Anybody figure it out yet? (100) parentheses 0.25 squared. 6.25. Ooh, okay. So now divide both sides by 6.25. And K equals 4 divided by that answer, 64. Sorry, you can't see on there. There we go, 0.64. Now, I don't have any idea what formula this is for. W equals 0.64 RI squared is our final answer. I find these questions kind of silly. I mean, why do I need to know this? It's just one of those things you just have to do as you get in higher education. All right, y varies inversely with both x and z. Inversely means we need to multiply by the fraction 1 over x and 1 over z. Okay, so y equals k times 1 over x times 1 over z. They tell us y equals 32 when x equals 4. And when z equals 0.05, and this is why it's good to have a calculator. Sorry, that looks like an L. It should just be a 1/4. So 1/4 times 1/0.05. Oh, wow, 5. How come? Oh, this is 5/100ths, and then it needs its reciprocal, which would be 100/5. Sorry. Thanks for letting me know. There we go. 0.05 is the same thing as 5/100ths. This is its reciprocal, so that would be 100/5. 4 goes into 120 times 5. No, 4 goes into 125 times, and then 5 divided by 5 is 5. That was an unexpected answer, so I was just curious. Okay, so it's 5. So now we have 52 equals k times 5. Divide both sides by 5. 52 divided by 5. I'm not in the mood. 10.4. Woo. So k equals 10.4 with our final answer as y equals, yes. Thank you. It's 32, not 52. Thank you. So this becomes 32. Do you guys remember how to cut and paste? You highlight it, press enter, then you can backtrack. 6.4. Is that what you got? Thank you. 6. So 6.4 times 1/x times 1/z. Which part? When I multiplied these two fractions together, I got 5. Here, let me see if I can show you. Sorry about that. You probably can tell I've been doing this while I've been taking 4th hour. So now we'll go on to number 43. They tell us in the book, because that's where I got this, that F equals K times X is a direct variation. F is the force in newtons. X is the distance stretched in meters of a spring, and K is the spring's constant. And the reason it has n/m is because this is newtons, this is meters, and they have to cancel correctly. Okay, so you're good. You've used it in MPI. Oh, cool. Excellent. Well, it says a force of 30 newtons will stretch the spring 10 centimeters. How far will a force of 72 newtons stretch the spring? The bad news is a lot of you think, oh, if I will just put this in a proportion, I'll figure it out. But this formula prevents us from doing that, okay? This first bit of information is really a backwards way of asking us to find K. So F is the force in newtons, so I'm going to put 30. Then I put K. And then the distance it's stretched is 10. So this tells me my K is, in this instance of this spring, is 3. So now what that does here with this equation is tells us that for this spring, this is the equation we need to use. Once you decide the equation, then you actually put in the next information and answer the question. Okay, so it's not proportional, it's direct variation, and without the constant, you can't solve the problem. Yes?